Okay, so this is Chapter 2, Section 7, and we're going to talk about polynomial and rational inequalities. So polynomial inequalities are where we have some function and it's either less than 0, greater than 0, less than or equal to 0, or greater than or equal to 0. And we want to find the boundary points. Okay, that's going to be a term that you want to know. Okay, so we're going to find the roots of the polynomial, and these are our boundary points. Now, I've listed out a bunch of steps here for you, and you can go ahead and read those. The first one, we want to make sure that we have 0 on one side and the entire polynomial on the other. And then we're going to solve the equation, so factor it as far as you can. And then those solutions are the boundary points. Then we're going to locate the boundary points on a number line. So we're going to draw a number line, and then we're going to choose a representative number called a test value. Okay, in each interval. And then we're just going to test if it's greater than 0 or less than 0 for what we want. And then we'll find our solution set. So let's go ahead and get started with an example. Here we have 2x squared plus x greater than 15. So the first thing I want to do is get 0 on one side. So I have 2x squared plus x greater than 15. And subtracting 15 from both sides, we get 2x squared plus x minus 15 greater than 0. And off on the side here, I'm going to go ahead and factor. And negative 15 and 2 is negative 30. And then we have a 1, so that would be 6 and negative 5. So 2x plus 6, 2x minus 5, and trash. And then x plus 3 and 2x minus 5. That's our answer. So our factors here are x plus 3 and 2x minus 5 greater than 0. So these are our boundary points, these points right here. So x equals negative 3 and x equals 5 over 2. So we're going to draw a number line. And we've got negative 3 and 5 over 2. And now we want to choose some test values. Okay, so I'm going to choose negative 4. I'm going to choose 0. And then I'm going to choose 3. Those are our test values. Okay. And plugging in negative 4, plugging in 0, and plugging in 3. Well, plugging in negative 4, I get a negative number in here, and I get, let's see, plugging in negative 4, I get a negative number in here. A negative times a negative is a positive, so it's positive here. Plugging in 0, I get a positive number and a negative number. A positive times a negative is a negative, and then plugging in 3, I get a positive, and I get a positive, and positive times a positive is a positive. Now I'm wanting values that are greater than 0. I want the positive values. So I'm looking on my interval here, where is my function positive? And because it's strictly greater than 0, it's not equal to 0, I'm going to have all of these values and all of these values, but not include my actual boundary points. So I have from negative infinity all the way to negative 3, and I'm going to use a parenthesis because we're not including 3, union 5 over 2 to infinity. And that is my solution, and then I should also see your graph there. Okay, so that's the answer to that first example. I'm going to go ahead and flip the page now, and we can look at an example of rational inequalities. Well, rational inequalities are similar, but they're rational functions, so we've got to be a little bit more careful with what we do here because we don't want to divide by 0. So first thing we want is our rational function by itself and then 0 on the other side. We're going to set the top and bottom equal to 0. Okay, set the top and bottom equal to 0, and those are our boundary points. Then we're going to put these on a number line, choose a test point, and then look at our solution set. So let's go ahead and look at our first example. I have x plus 1 over x plus 3 greater than or equal to 2. and I want to get it equal to 0, so I have x plus 1 over x plus 3 minus 2 greater than or equal to 0. And now I can go ahead and create a common denominator. So I'm going to multiply by x plus 3 over x plus 3. And I end up with x plus 1 over x plus 3 minus 2x plus 6 over x plus 3 greater than or equal to 0. And then I can subtract because we have a common denominator. So I have x plus 1 minus 2x minus 6 over x plus 3 greater than or equal to 0. And I can combine my like terms here. So I have negative x minus 5 over x plus 3 greater than or equal to 0. Now we have 0 on one side, we have one fraction on this side. And so what we can do then is we can set the top and the bottom equal to 0. So negative x minus 5 equals 0 and x plus 3 equals 0. So I'm going to go ahead and zoom out here for a minute so you can see everything. X is equal to negative 5 and x is equal to negative 3. Those are our boundary points here. And we want to choose some test values, so let's say negative 6, negative 4, and 0. And we want to look at those values here. So plugging in negative 6, let's see here. Negative 6 is going to give me, let's see, something positive on top and something negative on bottom. A positive divided by a negative, it's going to be a negative. Plugging in negative 4 is going to give me negative on top and negative on bottom. A negative divided by a negative is a positive. And plugging in 0 is going to be negative divided by a positive, and that's negative. So we have negative, positive, negative, and I want where my function is greater than or equal to 0. Well, I can include my boundary points now, and I want it greater than or equal to 0, so I want where it's positive. So I'm looking at this highlighted area here as my solution. Now we have to be careful here because we still cannot let our denominator equal 0. So if I have from negative 5 to negative 3, what would make my denominator 0? Well, looking at my function here, plugging in negative 3 would make my denominator 0. So I cannot include that value even though I have the equal to sign here. So again, this is where you've got to be really careful. I can't include that value even though I have this because it would make my denominator 0. But plugging in negative 5 is not a problem, and because it includes equal to 0, we do want to have a bracket there. So parenthesis on this side, bracket on this side, and the interval I'm looking at is from negative 5 to negative 3, and that's my answer. And that is the end of Chapter 2, Section 7.